Hello, this is Britt Caswell with another example video. In today's video, I'm covering example 2 from section 7-2 in the SavvasRealize Algebra 1 textbook. The goal of today's video is to use a table to find the product of polynomials. This multiplication method is also called the box method, if ever you're trying to research this somewhere. So what we're doing with part A here is we're starting by comparing multiplying binomials to multiplying two-digit numbers. Now remember, when we multiply two-digit numbers, we probably learned to break those numbers apart, right? So like 15, I broke it into 10 and 5, and 18, I'm breaking it into 10 and 8. All right, so we learned that you can break apart the numbers and multiply together their components, and then add those components all together. All right, so like I could take this 10 and multiply it. 10 times 10 is 100. 10 times 8 is 80. And then I could take this 5 and multiply it across. So 5 times 10 is 50, and 5 times 8 is 40. And what that does is that gives you the ability to add just these numbers that are kind of easy tens numbers, is what I like to call them, in order to get to your final solution. So 5 and 4 here makes 9, plus 8 is 17. So that's 170, plus another 100 is 270. So it makes it to where you can kind of use some mental math here, right? Now, multiplying together these binomials works the exact same way. So I'm taking this x and timesing it to each term here. So x times x is x squared, and x times 8 is 8x. So if I'm thinking in terms of distribution, I'm taking that x and multiplying it to each term in the second set of parentheses. And now I'm going to do that with the 5, all right? Essentially, I'm multiplying the 5 to each term. So 5 times x is 5x, and 5 times 8 is 40. So now I've multiplied the first term to each term in the second parentheses, and I've multiplied the second term to each term in the parentheses. So now I can add these together. Now remember, not all of these are like terms, right? I can't combine an x squared and a 5x. That doesn't work. But what's nice about this method is it makes these nice little kind of like striations, if you look at them, of like terms that go across the diagonals. So here I have x squared, 5x and 8x makes 13x, and then a plus 40. And so that's how we're going to be multiplying together those binomials. And in fact, you don't have to do this with just binomials. I could do a binomial and a trinomial, which I think is one of our next examples. So what they're doing here is they're asking us to find the area of this green rectangle. All right, which is really the same thing as that box method if you notice. So what I'm going to do is I'm going to find the area of each of these like sub boxes and then add them all together. All right, so the length of this box here is 2x, and the width of that box is 1x. So 2x times x is 2x squared. Now this right-hand box, right, my length is still 2x, but my width in this case is 3 units. So 2x times 3 gives me 6x. So then here I have a unit of 1 and a unit of x. So 1 times x is just x. And for this little tiny corner, I have a unit of 1 high and 3 across, which gives me an area of 3. So now I could take those values and I can add them together to find that area of the green rectangle, right? So I have 2x squared, and 6x and 1x together make 7x, and then a plus 3. So when I did this with my students, I had them drag these values over to where they would go in the box. So I'm just going to go through that with you guys. To make it easier, I'm going to go ahead and draw in the subrectangles. Although we don't necessarily need these subrectangles, right? We know kind of what we're doing. We're multiplying each number on the top to each number on the side, essentially. So here we go. So on this one, 2x times 5x, 2 times 5 is 10, and x times x is x squared. Oh boy, there we go. So I have 10x squared. Now 4 times 5x makes 20x. 2x times 2 makes 4x. And 4 times 2 is 8. So these are the expressions that I would add together. And remember, the only like terms that I have here are the x's because they have the same variable to that same exponent. So I have a 10x squared. 4x and 20x makes for 24x, and then plus 8. Alright, so let's go ahead and let's do this just one last time. So on this one, I'm going to start with multiplying 7x to each of these. So 7x times 2x is 14x squared, and 7x times 1 is 7x. And now I'm going to multiply the 2 times each of these. So 2 times 2x is 4x, and 2 times 1 is 2. So now that we filled in that area model, now I'm going to collect those like terms. And the only like terms I have between these four numbers is the 7x and the 4x. So I have 14x squared, and 7 and 4, that's 11x, and then I have a plus 2. So there we have it, y'all. That's how to use a table to find the product of polynomials. Until next time.